In this section, we're going to give an introduction to the unit circle. Now, we just finished with law of sines, law of cosines, and even reviewing SOHCAHTOA, and all of those things have to do with triangles. And so why are we going into circles? How are circles and triangles all related? And really, when we're talking about all of those triangles, what's really important is the different angles that are created. And to really explore all of the different possibilities with angles, well, we need to think, well, what happens if you go all the way around? So for example, when a snowboarder goes off a jump and does a full rotation and lands in the same orientation that he started, well, we call that a 360 because that is going around in a full rotation. And so the first thing we need to make sure we understand is what all of these different increments are going around the circle. So kind of looking at these different options that we have here on the page, if you go a quarter of the way around a circle, that's 90, halfway around is 180, 3/4 of the way around 270, and all the way around back to where we started would be 360. Okay, one other important thing to note here is that we're always going to be starting on the x-axis in the positive direction. So from all of these, I am starting from the x-axis in the positive direction. And then I am going counterclockwise from there. And so that's how we're going to measure these angles. And so as long as you know where your starting position is and those various different increments, then that's going to really help as we continue to explore this. So now we're going to go from just talking circles in general to the unit circle. And we call it the unit circle because we're going to talk about a circle with a radius of 1. So that unit is as simple as we can possibly make it. So, we could talk about a circle with a radius of, 5 or 7 miles or 0.23. And kind of the simplest version we can come up with is a circle with a radius of 1. And the radius, remember, is the distance from the center of a circle all the way out to the edge in any direction. So in our unit circle, from 0, 0, from the origin, going out to the edge of a circle, the radius would be 1. And so that's why this point right here is 1, 0. The x is 1 and the y is 0. This point up here is 0, 1, because I'm going to go up 1, my radius is 1, and that coordinate point is 0, 1, taking into account my x and my y, of course. Okay, and then going out here, the radius of 1 on the unit circle, the radius is always 1 on the unit circle, so going to the left, I have a coordinate point of -1. And then going down, well, that's going down 1, so my coordinate point is going to be 0, -1. All right, those are kind of the simplest points that we can consider on the unit circle. So let's go ahead and see what's going to happen when I pull in something that looks a little bit more complex. So here, I'm just going to talk about any angle theta. And we need to know kind of how to deal with any angle theta that's a little bit more complex than just those 90, 180, 270, 360s. And so for any angle, when I am looking at the radius, which is going to be the hypotenuse of the triangle, then that radius on the unit circle is 1, because that's still going from the center to the edge of the circle, so that's still a radius, so it's going to have a radius of 1. Now continuing the same thought process, I have my angle right here, which goes out at a radius of 1 because I'm the unit circle from the center to the edge of a circle anywhere, which is the radius, is going to be a value of 1. So the hypotenuse of this triangle, which by the way is a right triangle, so that's going to be a right triangle because I'm looking at a horizontal and a vertical distance for my legs of the triangle. I have a hypotenuse of 1, and I'm going to be looking at this point on the circle here. So from the origin on my coordinate plane, I'm going to go to the right some amount. So I'm going to go to the right some amount, and I could call that amount x, which is going to be my x value on the coordinate. And I could go up some value y, which is going to be my y value of this coordinate right there. And what we're going to look at is, well, what are some other ways that I can think about or maybe find that x and y coordinate? So how can I find those values? And if you are just kind of wanting to get through it and kind of know the fast way and know the memorization based way, then you might just want to perhaps memorize that the x value is found by taking the cosine of theta. What is theta? Theta is an unknown angle, or represents any angle in our case. And so here is theta. Whatever that angle is, if I take the cosine of that angle, then that will give me my x value. Similarly, the y value can be found by taking the sine of that theta. So if here's my theta, whatever that angle happens to be, maybe 20 degrees, 30 degrees, 180 degrees, 265 degrees, anything, my x value will be the cosine of that theta, that angle, and the y value will be the sine of that angle, that theta. If you want to kind of continue this thought process and understand where that cosine of theta being x and the sine of theta being y comes from, it's really all from our SOHCAHTOA right over here that I put right here. So if I kind of pull this triangle out right over here, and again we had a hypotenuse of 1 because it's a unit circle, so a radius of 1, with some x value moving to the right, some y value moving up, and let's think about sine of theta. So what's sine from SOHCAHTOA? That's opposite over hypotenuse. So that's opposite over hypotenuse. So sine of theta is y over 1. Oh, well, y over 1 is just y. So that's why the sine of theta is y. So sine of theta is y. Okay, great. Okay, let's try the cosine. So how about cosine of theta? Well, SOHCAHTOA says that c is AH. So the cosine of an angle is the adjacent over hypotenuse. So from this angle here, the cosine would be adjacent x over hypotenuse 1. So cosine of theta is x over 1. X over 1 is, of course, just x. Therefore, the cosine of theta is x. So the cosine of theta is x. So let's do some practice with this idea. So I went ahead and drew a few points around the unit circle, A, B, C, and D. And let's see if we can answer this question. What coordinate is equal to the sine of 100 degrees? So the first thing I'm going to think about is the degree. I have 100 degrees. I want to know about where is 100 degrees. And remember, we're always going to start on the x-axis in the positive direction. So this is going to be my starting position. And I'm going to go in the counterclockwise direction. So I'm going to be going kind of up and to the left from that starting position. So 100 degrees, okay, well let's see here. So 90 degrees is there, so I'm going to go at least a little bit past 90 degrees, and somewhere around there is about 100 degrees. So something like this is about 100 degrees. So where is 100 degrees? Well, it looks like it's lining up with B. And we don't know necessarily exactly that it would 100% hit B. It might be very close to it. But from all of my points, A, B, C, and D, if it has to be one of them, then it's definitely B. Okay, so I know that it has something to do with B. Now, the next question is it the x coordinate of point B, or is it the y coordinate of point B? And when I look at what it's asking for the sine. And you may just go from memorization from that last slide and say, okay, well, is the sine, does that correspond to my x coordinate or my y coordinates? And the sine is my y coordinate. So the sine is going to be the y coordinate. So this corresponds to the y coordinate of point B. Here's another example. We want to know what coordinate is equivalent to the cosine of 350. So again, first of all, I'm going to go ahead and consider this angular measure of 350. And we want to make sure that we know where my starting position is. That starting position is going to be on the x-axis in the positive direction. And I'm also going to be going up and left in a counterclockwise fashion. So let's go ahead and go around. So I have 90 degrees, 180, 270, 360 would be all the way around. So 350 is just a little bit less than 360. So it looks like kind of measuring that angle of 350 degrees, just shy of 360 degrees, would land me on point D. So I know that I'm going to be doing something with point D. And then the next thing that I need to know is it the x-coordinate of point D or the y-coordinate of point D? Because remember, each of these points, A, B, C, and D, and any other point on the circle, they're all in the coordinate plane. So they're all going to have an x and a y. So I need to know, well, is the cosine of 350 referring to the x value or the y value? And again, you may just kind of go off memorization maybe after you've already understood the math, so you don't have to redo the math every single time, and kind of remember that the cosine refers to the x value. So the cosine refers to the x coordinate of point D. One more example like these. This question says, what coordinate is equivalent to the sine of 225? So I have my starting position here on the positive direction on the x-axis. I'm going to measure all positive angles by going up and left, or the counterclockwise position. So 225. Okay, so up to there, it would be 90. Down to here is 180. I need to still keep going to get to 225, past 180. But I don't want to go to 270. That would be too far. So maybe I would go to about right there. So that looks like that's definitely going to correspond to point C. So if I go about that far, that's going to get me to point C. So I know I need something with point C. And then is it the x-coordinate or the y-coordinate? Well, if it's sine refers to the y-coordinate here. So I know that this sine of 225 is referring to the y-coordinate of point C. Let's think about one last thing here in the unit circle. I want to talk about the signs, as in positive and negative, of the different coordinates in the different quadrants. So we already talked about the points that were right on an axis, either right on the x-axis here, or on this side, or right on the y-axis here, or down below. We kind of know what those are. But let's go ahead and talk about any points that are in between the axes in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So anything in quadrant 1, let's think about what the signs are of my x value and y value. So in quadrant 1, I would be moving to the right, which is positive, and up, which is also positive. So my signs for any coordinate in quadrant 1 are going to be positive to the right and positive up. Let's go ahead and talk about any coordinate in quadrant 2. So in quadrant 2, from the origin, 0, 0, I would be moving to the left, and to the left is negative, and then up, which is positive. So anything in quadrant 2 would be x value that's negative to the left, so a negative x value, and a positive y value because I'm moving up. So anything in quadrant 2 is going to be negative going left, and then positive because I'm moving up. All right, quadrant 3 over here. So starting from the origin, I would be moving to the left some amount, and then to the left is a negative for my x value, and then down on my y value. So down, that would be a negative on my y value as well. So anything in quadrant 3 would be negative, negative. So this is some kind of negative, negative. Last quadrant here, quadrant 4, I would be moving from the origin, 0, 0, to the right, that's an x value that's positive, and then down, so that's a y value that's negative. So quadrant 4 is positive, negative. So positive, negative, we'll get that in there.